Okay, we will recap what we learned before the Chinese New Year breaks. So previously, what we do is studying about this network, right? So there will be a forward pass, backward pass. Then there are 6 rubrics, 6 box here with number of activity, duration, earlier start, earlier finish, later start, latest finish. Then we do hypothesis. We guess whether got success or not success by using the z equal to x minus mu divided by sigma. Again, for z value that we read from this table, for normal curve area here, we are using standard variation. We are using standard variation. Okay. So today we'll just recap. This is another information that I extract from other textbook. Just a recap, I refresh. Basically, you already learned what chapter 5 you should learn. So this is add-on information. So for PRT, you have bubbles and then the time and all these things. So some textbook, they put the network in 2 presentation. One is the blast point. So it is you see in the previous example. So one activity go to the 3 activities, and then there's a stage. Usually at the last stage, last phrase, we call it sync source or sync process, where more than one activities combine and then join with the last activities or one activities. So they are blast point and sync point. Blast point and sync point. Okay. So these are the things that you're already familiar. Gantt chart, milestone chart, and PERT chart. So these are the differences that we have. And previous example, we convert Gantt chart into PERT chart or network. Okay. Now, this table you will see in your test or final exam. So you will see sequence events with the tables and activity 1 to 2, right? Activity 1 to 2. Or sometimes I'll just put activity 1 and so on. Then title A, B, C, D, K. Intermediate predecessors means this one is the previous activities that you need to follow. So you'll see A, B, C, D, E, F, G. Then activities times, this one is in week. So read carefully. Sometimes the question will give in weeks. Sometimes the question will give in months. Sometimes the question will give in years. Then you do hypothesis. Right? So this is the careless mistake usually student will overlook when we give you a table. You just assume that it's in month or weeks. Then the question asks you years, or the question asks you days. Then you answer, you give me weeks, then wrong. Okay. So for weeks means you assume 7 days per week. If you ask you months, you assume 30 days per month. So if you ask you per years, we assume you have 365 days in a year, right? So all these construction, you need 2 input, start and complete, sequence, and all this. Then these are the typical PRT network, or yeah. So you base on the table, then you draw this network. One I want to highlight is when you draw the network, make sure you are showing arrow, and your arrow is straight. Your arrow is straight. So when you draw network, don't give me curve, and then then label carefully. That is my reminder. So previously we also learned about critical path. Critical path is the maximum duration you need for the projects, and you can count by a few ways. There are 4 ways that you can identify the critical path. So you have learned all this already. Just a reminder. Today, just a revision for you guys. So how to determine the critical path. So the first, you calculate the longest duration by studying path. By studying path, you elaborate lah, this one. So this one, you calculate path A is what, 1, 2, 3, 4, then you count how many days. Then B, C, D, and so on. Okay, then you pick the longest day. Second, you build the 6-box Rubik's. Okay, so you have these two columns, and these two columns. So the second one is you look at the center one, which is your earliest start and latest uh, latest start, right? The third method is look at this column. You look at EF and LF. Okay. The last method, the fourth method is calculating the slack. Okay. So slack is you take earliest start and latest start. You get a number 0. That is the critical path member. Okay. So there are 4 methods. There are 4 methods. Usually, this kind of question will appear in question related to network. It will ask you how you determine critical path. So you need to mention these 4 ways. You elaborate. So I'm looking for these 4 answers. Then you mention accordingly. These are the 4 answers. Okay. Any question for this critical path? Anything that you are not clear or you forget already? Okay. So how to determine critical path? There are 4 ways. So one is you calculate the longest duration by looking at the path. Second, you look at the Rubik's or the cube or the 6 cube or 6 box. You look at the middle part. If it has have the same number, then that is the critical path member. Or the third method also refer to the 6 box Rubik's. You look at the back one, the EF equal to LF. Okay. Normally these two will be the same. Normally these two will be the same, but when you elaborate on the method how to determine the critical path member or critical path, you break into 2 points here. Point 2 you refer to the middle, point 3 you refer to the back. Basically they are the same point, but you try to break into another point. Then the last one, you calculate the slack. Okay, if the slack is 0, slack means you cannot play around. There's no free time for you to move around. There's no flexibility for you to move around, right? So if the value is 0, means you die also need to complete it. Then slack 0 is fine. So the rest you just read just for your info. Okay, so what is the difference between PRT and CPM? This one usually we will ask in the section A question. It will ask you some theory, ask you to differentiate between 2 methods or 2 models. These are the points that we expect you to know. So these are the points that you read and maybe memorize. Okay. So this one, you see, PRT use 3 times estimates. So here you have optimistic, average, and pessimistic. You remember this one? Previously, we have A, B, and N. This one. But CPM, you use 1 time estimate. You are using the normal times. You only want one value only. Then PM, PRT, they use dummy activities. If you need to use dummy, then you use dummy. Then PRT is used for R&D projects. CPM is used for construction projects or big projects. Construction can be building, can be a car, can be a aircraft, and something big. Something big. Then PRT also Percent of complete is almost impossible to determine, except you those that already completed. This one PRT. But CPM you can calculate the percentage of complete. Okay. So this is another type of network which we will not ask you in your assessment. This is for drafting. And some also in some construction management. This is not an official diagram, right? It's just a sketch for you to determine whether it works or do not works. Okay, so you look something like this, and then you will the differences between the one that you learned previously compared to this one. This is called GRT or graphical evaluation. So you see there's a reverse back arrow. Previously, the one that you learned always from the left to right, start to end. But this one, graphical one, has a look back. And then the arrow also is not straight, it's a curve. Then you have a different shape lah. You have round shape, you have triangular shape, and so on. Okay. Okay. So there are three parameters. There are three parameters, so we call it dependencies. One is mandatory dependencies, which is mandatory parameter that is cannot change. Okay, such as electing the wall of the house before you put out the roof. For example, there are some process that you need to start first before you start something else, right? You need to build the wall of the house before you can put on the roof. And that is a fundamental logic that you should have a mandatory dependencies when you develop a network. Second one is more flexible one. It's called discrete dependence. We call it soft logic. This one is depend on the experience or decision of the PM, project manager. Sometimes it's like when you're cooking, some people, they like to put in salt first. Some people, they like to put in something else first, right? So this one is called discrete dependency. So some dependency, this one is, the sequence actually do not affect the output. I mean that you put this A first or put B first, it doesn't affect the final products. This one, external dependency, this one is outside control. Outside dependency means outside control. What is outside control? Is anything that outside the company. Okay. So this is company or your process, internal process. Anything outside is called external dependency. So you can elaborate, you can think outside the company. What is outside the company is something happen to the society. Like for example, political change, political parties, some policy going to change. Maybe some economic factor. The country is having a war, then the economy will go down. For example, what else? Something like that. Economy, society, and maybe some disease. For example, COVID. COVID come, it's outside the control. All right. So some project you cannot do, some construction you cannot do, and so on. Okay. So there are three. Slack time, you already know, you take L minus E, means earliest time minus latest time. So you already know. Okay. Okay, so this is elaboration. So from analysis, it tell you that event 4 is not on the critical path. To go from event 2 to event 5, this one, 2 to 5, you have two routes. On the critical path required 7 weeks. Taking note 2, 3, 5. So 2 to 3 need 5 weeks. 3 to 5 need 2 weeks. So total 7 weeks. But 2, 4, 5 you need 4 weeks. So therefore event 4, which require 2 weeks for completion, should begin anywhere from 0 to 3 weeks after event 2 is completed. So it just means that event 4 you can start lah after 2 weeks. Okay. So during these 3 weeks, these 3 weeks means what? If you go 2 to 2, 3, 5 is 7 weeks. 2, 4, 5 is 4 weeks. All this activity you are required to do it anyway. Right? So it's only like 2 process lah. One team go to do 2, 3, 5. Another team you do 2, 4, 5, but you meet at 5. So one team they need 7 weeks, one team you need 4 weeks. So there is differences of 3 weeks. So during these 3 weeks, you can do anything that you can do other things that might useful to the companies, right? For example, at this time maybe you can borrow your stuff to other department, then come back after you reach another team reach activity number 5 or event number 5. Okay, please go on. Sometimes the question will ask you what is the benefit of having slack time. Sometimes the question asks you what is the benefit of having slack time. So you think slack time means you give some flexible for the management to use other resources, people, to complete the next event. Yeah. Okay, the rest you read. So this one, calculating the slack time, you already know how to do. This one might be a bit messy a bit, but if you build the 6 box, basically you arrive at the same number. Okay. The rest you read. So in the 6 box, you have ES, EF, LS, LF lah. So this is another presentation. Some textbook they use like this. Some textbook they write C, then 2, 8, 10, bracket lah, bracket on the top, bracket at the below. Basically, the one that you learn, you already convert this 6 number into 6 boxes. It's more organized now. Okay, more organized. Some project program means you when you do project planning, some old program they present you in this presentation. Some old one, old program. Okay. So I will not go deep into this one since we already learned how to do this one already. This is just additional information for you lah. It's a different in the exam. Don't write this one. Don't write in this format. If the question asks you to write your answer in ES, LF, or LS, LF, and LS, right? The question will give you direction. It will give you a sample of drawing this one. So you need to follow. Don't use the one. This is just to show you that there's another presentation. Okay, backward pass, forward pass, you already know. Okay. Now this is called iteration process for network. So it's from the top to bottom. It can be one question to ask you about network planning. You elaborate. It's the essay section. You use this table to elaborate. So there are five big blocks. You start from develop schedule, followed by resource control, followed by management review, then whether you document it or not. Then in the middle here, during the review, if the review result is fail, then it go into feedback again. Then collect feedback, then go back to the schedule. Okay, so there are 5 blocks. So develop schedule, resource control have 3, gate, cost, time, resources. You have cost, time, and resources. Then yes, no, yes, no. So when you need to make decision, you're using diamond shape. So for your FIP report in your process in your methodology chapter, you need to show your process. So when you draw your process in your FIP process chart or research methodology chart, make sure you use the correct shape. Huh? So when you have a yes, no, then you use diamond. Usually the below one is yes. The one at the side, left or right, doesn't matter, is no. Okay. Then you go to management review. Then you go for planning, schedule, abilities. Then yes or no. If it's yes, so you review what you replan, schedule, and acceptable. The plan and schedule, is it acceptable? Yes, you proceed with you document a plan and schedule. So this is how you develop the schedule, right? You change all these blocks into essay form, into paragraph. Okay. The question will give you a scenario. Then you pick the scenario, you elaborate, you draw this diagram, then you elaborate. Basically, the first paragraph or first 2 lines or 3 lines, you write. First stage is develop PRT schedule. Then second one, you say followed by resource control. Inside resource control, there are 3 control block there, right? Then yes, no, yes, no. What happened is yes. What it go? If no, then go where? So you elaborate lah. So the second middle part in your essay or in your answer is a bit lengthy, you expect, because here you have 1, 2, 3 points here. Okay. For the first part, it can be 1 line. Then here also 1 line. Here also 1 line. So if this kind of question come out, this is one point or 2 point. 1, 2, 3, 4, 5, 6, 7. 6 lah, maybe 6 points. For 6 plus diagram, maybe 10 points. Diagram is maybe 4 marks. Then elaboration is 6 marks. So you mention this one, 1 mark. Mention 3 marks. This one, 1 mark, 1 mark. So 1, 2, 3, 1, 2, 3, 4, 5, 6. 6 plus diagram, 10 marks. Okay. Okay. So this one you read lah. So another one is called network replanning. So what can you do to make it better? So this is to stop how many programs or project follow the exact schedule from start to finish. Is to do replanning. So here is network with slack time. So suppose activity 1 to 2 and 1 to 3 required manpower for the same function unit, from the same function unit. So 1 to 2, 1 to 3, you require same. Okay. So upon inquiry from the PM, the functional manager, you need to assess whether which one is more important, means priority. Give priority to which one is 2. So he can reduce activity 1 to 2 by 1 week if he shift resources from activity 1, 3 to activity 1, 2. So you see, 1 to 2, you need 3 weeks. 1 to 3, you need 2 weeks, only 2 weeks. So he can reduce activity 1, 2 by 1 week if he shift resources from activity 1, 3 activities. So in the real case, because here in the original plan, 1 to 2, you need 3 weeks. Then process 1 to process 3, you need 2 weeks. Then you can do replanning here. Because when you complete 1 to 3, you need 2 weeks already. Then all the stuff that is doing 1 to 3, nothing to do already. So what you do, you transfer resources that doing 1, 3, move to activity 1, 2. So when you have resources already, the time will cut short. This is how you buy time. Okay, this is how you buy time. It's called replanning lah. So it just tell you, however, 1 to 3 increase length. Okay, this one nothing. So Um, okay, this one, this chart between the top and bottom, it means what happened if the manager, the functional manager flip the time. Means maybe it tell you, oh, I need more time to 1 to 3. Then the flow, the network will change from the top to bottom. You see there's a flip number here, 2, 3, and flip. So here become 2, 3. When you flip the number, you do the analysis from forward pass, backward pass. You see what happened to the total weeks of completion. Critical times become 15. From 15, I don't have the unit, I just assume week. So from 15 weeks original plan, the functional manager flip the time because it will shift around the resources. It flip around. The total time at the end is 14. Save 1 week in total projects. This is called replanning. Okay, so some part of the question, especially when it comes to final exam, it will ask you, is this possibility to do replanning? So it asks you to sit there and look at your answer. Which one can you switch the time? Okay, or the question directly give you, like, for example, the one that you see on the screen here. He say another scenario, like in section C, he asks you to think a little bit. Section C usually is the question that you need to think a little bit. Okay, so section C kind of question will ask you, give you another scenario. What happened if the functional unit suggests activity 2 to 3 increased by 1 week and reduce the time from 1 to 2 to 2 weeks? What is the effect? So you need to do, redo the calculation, and then you tell me, okay, for example, this one, original times is 15 weeks. It will reduce to 1 week. The effect is reduce 1 week. You can complete the project 1 week early. Now, because of this 15 to 14, the possibilities of success will increase. If you recall back how to do the analysis, the success rate will increase. Okay, or depend how the question asks you. Okay. So for example, from your diagram here, 15 days, the question asks you what is the success rate if you commit 20 days. The success rate will increase. It will increase a little bit, a little bit. So also, if the question asks you what is the success rate if it do maybe 13 days, the percentage will also increase. Okay, so this is replanning. So there are two methods or two strategies they can do when you go into industry later, right? When you go to work. One is you look at the resources. Another one you look at resources. One is you do leveling. One is use priority. Priority. So leveling means attempt to eliminate the manpower peaks and valleys. So sometimes you don't need too many operators. You just level it out. Right, maybe the month of for example, you are the company doing the winter clothes. So winter clothes you need to sell before the winter, right? And nobody go and buy during the summertime. So your summer times the sales will drop one. So you don't need so many staff during the summertime, right? But you need to rush for production before the winter. Okay, so it's called leveling. And then allocation. This one you read. Allocation means you transfer your resources to another one. So when you have more people to do it, then you will shorter the time. Okay. There's one called series, one called parallel. So you will see parallel and series presentation. Okay, the rest you read. Segmented chart or network. Segmented means you pull out one of the process. Um, for example, this is the overall master chart, the one that you've seen in the previous exercise. This is a master chart. But within the department itself, it can break into another chart. So when you take something from that small, like for example, this, we take the process D here, we expand, it will become another new chart. So this one is called segmented chart. Okay. Okay, so this one, if you work in the oil and gas, you will see a lot of this chart. You click one button, it will give you another chart. Click one button, give you another chart. Okay. Estimating this one, you know that you have 3 times optimistic, pessimistic, most likely, and you're using this equation a plus 4 m plus b divided by 6 y divided by 6. Because you're looking at normal distribution, this you are actually looking at the 6 sigma profile. Means you cut the graph into 6 pieces. Okay. And then the standard variation. Standard variation is taking b minus a divided by 6. Okay, so these are the differences. There's a difference between variant and standard variation. So variant is square, sigma square, and then sum of x minus mean, the individual value minus mean in the table, divided by number of n. You need to square it. So variance, you need to build a table. Just recall how to do in mathematics. So number 1, 2, let's say you have 10. Then this is the data or your xi. Data, let's say 3, 4, 5, and so on. To do this calculation, you need to calculate the mean x bar. Okay. Then you take this one is xi minus mean or mu in this on the slide. Then another, you bracket, you square the value over here. You square this value. Then you square this value, you get the sum of xi minus x square, x bar square. You get this number. Then divided by n. This is the n. You get your variance. Okay, it's the same lah, but it's just that one is for population, one is for sample. Same concept, we just change the alphabet, the notation inside the equation. Okay, just need to be careful lah. Variance is square. Standard variation, you need to pull the square to the right hand side. You square root the answer. This one is to calculate hypothesis one. You project, you use the normal distribution chart, Z value. Okay, this one you already learned. So this is for your info. So this is the application of standard variation. It asks you what is the standard variation for the total system. Okay, you calculate the square, sigma. Then you square root it, you get 1.25. This is explaining why you divide by 6 in the equation. So recall this one is a normal distribution chart. Normal distribution means if you cut the graph, the area on the left will same as area on the right. Okay. Then in the middle, you have 100%. You cut another 2 sigma, 1 sigma, you will get 68% accuracy or presentation of the data. If you expand the graph to 2 sigma, you will get actually four segments. 2 on the left positive, 2 on the 2 negative. So the area will become 98% of your population. Then you extend another 2 column to the left and right. Then you have 6 segment to the left, 3 segment to the right. Okay, total you have 6 sigma. So you have heard about the certification for 6 sigma, green belt, black belt. It's actually using this approach. For Sony, if you go to and work into electronics, Sony, Intel, they are using 6 sigma calculation. So they are estimating a very high accuracy, 99.7% of your data. Your error can be very, very low. So if you are the supplier for Intel, for those semicon, you need to be careful. For example, if you are a supplier for mechanical, let's say this is the mounting board, a mounting case for some of the bracket in the for computing or for desktops. There is a tool here hole that you need to screw the things. The dimension, let's say 5 mm, will be plus minus 0.01 mm, for example. So if you out from this range, you are failed, the whole lot will reject. I'm talking about million pieces. When you produce in the production, you produce minimum 1 million piece in the industry. So if you're small scale, then maybe smaller volume. So you need to be careful when you have this. Okay. So these are the expected answer in your working during the test. If you're given optimistics, most likely pessimistics, we expect you to calculate, develop 2 more columns in the answer. Then you write your answer. Your small working, you can write beside the table or below the table. Please arrange your answer in the good order. So for example, if this kind of question come up, you build table on the top. All your calculation, please write neatly. Don't jump here and there. So if the first one you do, second one you do, third one you do, you can draw a line, then you label clearly. I've seen student, he give table like this, then A, he write here, jump to E, jump to F, then draw arrow, point to B, or this is B. I will circle this one, I put question marks. Then if you calculate wrong, I will straight away give you wrong answer. I will not calculate the marks. Okay, so if you want to write neatly and show me where how you do it. Okay, usually this one, we have 2 marks for each of the point here. So for example, this sigma, this value is 2 marks. One is the one that you write inside the table, and then one is your working. So if you write a value without working, I will circle, I will put question mark there. No marks for the answers. You need to show me working. Remember, you need to show me working how you get, for example, how you get 4, how you get 5, or how you get 4/6. Okay, the rest you read. Rest you read. right? It depends on where you fall into the region there by using the calculation z equal to something. Okay, this also you read how you do. We already learned already. Okay. Next section is 5.9 on total plannings. You have two objectives if you have a schedule. So primary objective on the schedule is best time, least cost, and least risk. You want to get the optimum time in your project. You want to reduce the cost. You want to reduce the risk. These are the three main purposes why you need to do the network. Okay, time, cost, and risk. Secondary objective have these 6. So you have primary and secondary. So you have 3 points for primary and 7 points for secondary. So question will ask you primary objective and secondary objective. Usually three answer. Okay. Crash time we already mentioned. Okay. So it just tell you that this is how you do on the crashing cost, how you estimate crashing cost. So if you do a network, you can plot the graph, program cost versus completion times in weeks. How you do it? You start from activity A. If you crash A, what happened? If you crash F, what happened? If you crash E, what happened? If you crash B, what happened? Okay. So you start with A, then F. The crash calculation is by following the sequence from low to high. For a table, for example, how you build this table, you see activity A, normal time is 4. If you have crash of 2 weeks, the cost for normal 4 weeks will be 10,000. If you crash, it will be 14,000. So if you having these two cases, crashing cost per week will be 2,000. How you get 2,000? You get this one, 14 minus 10, you get 4,000. You divide by 2, you get 2,000 per week. How you get 1,500, for example? You take 100, 1,000, 9,500 minus 8,000, crash 1 week, so the value is 1,500. Okay. Then how you work this out? How it works out? You plot the graph, y-axis, x-axis. Okay. Then you start from the back here. How you get 1,200? You add all the value. Okay, you add the normal value here. You get 1,200. You draw a line. Yeah, you add this value. You draw a line from the graph. Okay, this is the maximum duration for completion times. How you get this 23? You do your network analysis, get the critical path. You get one number here. You extend, put the point here. How you derive this curve? You look at the normal graph here. Normal graph here, you pick from low to high. Here, 10,000, 8,000, 12,000, and so on. So if you crash A, here, if you crash A, okay, if you crash A, okay. So if you assume there's no new critical path developed, activity A, F, E, B would be crashed in that order. Okay, so if you in the network, in your network. This one fail. After this one fail, you go to B. It will go. It will be E, F. So you look here, A, A, B, E, and F. Okay. So this one, you look at the crashing cost, crashing. Okay. So this one, the sequence here will be from A, F, E, B. A, F, E, B. So maybe I slow it down a bit. A, E. Okay. So the sequence just now I mentioned, look at normal, right? Actually wrong. It's not look at the normal cost, it look at the crash. Like this column. Okay, you look at A the lowest, then the critical path is A, B, E, F. The critical path is the one that I highlight with the dot circle. So A, B, E, F. So 2000 followed by 3000, then followed by 6000, then the last one 12,500. So you manage the lowest crash first. So you start from A. So 120,000. How you move to the next point is from here. Crash 2 weeks. Crash 2 weeks, 23 minus 2. You arrive at 21. You extend up. You draw a line. Then, okay, then this point, this point, 22,000. The cost will be, crash cost will be 14,000 if you crash for 2 weeks. All right. Okay. So I draw the vertical line first. I draw the vertical line first. So 2 weeks, you reverse 2 from 23 to 21. Then you go to F. F is 3 weeks. So 21 reverse back 3 weeks. Okay. 21, is it 3 weeks? Sorry, 5 weeks. 5 weeks. A to F, F to E. So you have 2, 2, 3, 2, 3. 2, 3, 5, and 2. So you draw the line. You draw the line. Then you go to pick the vertical line. So this one got 2 weeks is 4,000. So if you have lost for 2 weeks, you crash for 2 weeks, you increase 2 week cost. It's 2,000, you lost, you crash for 2 weeks, the cost will increase 4,000. And so on. You will work back all the procedures. Then you join the line, you arrive at one point. So this point is called minimum cost total crash. You arrive at one value. Okay. So you see, a normal operation is 120,000. But if you crash, from A to B to E and F, let's say the worst scenario, means you're estimating the worst scenario. This is a risk assessment, procedure. If you crash all the process, your cost will increase from 120,000 to 157,500. Okay, if all the critical path members fail or crash. For A crash for 2 weeks, B crash for 5 weeks, E crash for five weeks, F crash for 3 weeks. The cost will increase. So this is how you do. So you increase your responding time. The responding time would be reduced from 23 weeks to 15 weeks. What does it mean? If you slow, do every time go smooth, everything goes smooth, you can guarantee that it can complete within 23 days, 23 weeks, for example. If everything goes smooth. But if you have 4 activities fail and keep crashing, your response time will reduce from 23 to 15 days, 15 weeks. This is a risk assessment. Why this is the what response time means? You need to put out the fire, right? Every time crash, you need to put out fire. So it reduces your response time to the customers. Response time means you deliver time for you to deliver the goods. Okay. Okay, crash time. This one you read, This one you read. This one for your info. This one also your info. This one your info also. This one you read, This one you read. This is an additional info for you. I won't ask you this one in test. Okay. This is old information. But just to get ready you when you read the old materials. So sometimes you have finish to start means you draw arrow from the finish to start next activity start point. This is a normal question, normal question setup. Some if you go to industry, some they join start to start. When you join start to start means these 2 activities start at the same time. Start to start. Some is finish to finish, means they focusing on the end date. 2 activity must end at the same time. They doesn't care when you start. Okay. Some is start to finish. So it means this one start and finish must meet the requirement. This one maybe two process already lah. 2 process. Okay. Mean that if you need to assembly something, another thing that you need to put on top, this one must be finished first. Then only you can put on top. So you will use the finish start to finish, and so on. This one you read. This one you read. Some do you use percentage? This one you see in the oil and gas industry. Every day they will show percentage of completion, real time update. How depth you go in the drilling, how many percent you have to do the drilling, and so on. Okay, this one you read. Yeah. This one also you read. So there is a difference between slack and lag. Slack is you measure within activities. Lag is measured between activities. This one you read. I won't ask you this one. Okay, so the quiz you go through in the slides. Okay, all right. Make sure you sign attendance. We end the lesson here lah. Okay, see you guys next week. Next week your test already.